In this video we want to do a example of a Taylor and Maclaurin series free response. So first of all, you see it says given that the function f is continuous and differentiable throughout its domain, and that f of 5 is 2, f prime of 5 is negative 2, f double prime of 5 is negative 1, and f triple prime of 5 is 6. Alright, write a Taylor polynomial of degree 3 that approximates f around 5. So let's just remind ourselves of this big thing we've got to memorize, and that is that f, or the nth derivative of f, evaluated at a, multiplied by x minus a to the nth power, all over n factorial. This is how we do the Taylor series. Okay, so for part A, for example, we know the 0th derivative. That just means the function. So we've got 2, and then we've got x minus 5 to the 0 power all over 0 factorial. I'm going to go by the formula here, but I'll clean it up at the end. So next, our next coefficient is negative 2, because that's the first derivative's value at 5. So the first over 1 factorial. Remember that the derivative, what derivative we're on, the power, and the factorial, what we're doing to the factorial, are all the same. So we had, 0th derivative, 0 power, 0 factorial. First derivative's value, first power, 1 factorial. Okay, so let's keep going here. Now we're doing the second, so negative 1, get x minus 5 to the second over 2 factorial. And last, we've got a positive 6. That's 5 cubed over 3 factorial. So if we wanted to clean this up, we would just, let's start by looking at the first bit. Anything to the 0 is 1, 0 factorial is 1, so the first term is just 2. Then we've got 2 multiplied by x minus 5 to the first, so it's just this. Remember, just those first two terms, this is the tangent line. Okay. All right, now we've got 1 over 2 factorial, so that's 1/2. Then x minus 5 squared. 6 over 3 factorial, well, that's 1, so we just got plus x minus 5 cubed. So there's the Taylor polynomial of degree 3 that approximates f around x equals 5. Okay? So part B says, okay, use that and approximate f of 5.1. Well, now all we do is plug 5.1 in. We'd use our calculator. Probably to do that. Well, maybe we wouldn't even really need to. We'd have 2 minus 0.2 minus 1/2 multiplied by, well, 0.1 squared is 0.01 plus 0.1 cubed, so 0.001. You could use your calculator for that, or you could maybe do that even just in your head, but whatever you get, that's your approximation of f of 5.1. Okay, so now part C says let g of x equal f of 2x plus 5. Write a cubic Maclaurin polynomial. All right, now remember that a Maclaurin polynomial, that means that it's around x equals 0. Okay, so a cubic polynomial, so we're going to need to go to the third derivative. So let me start, g of x is equal to f of 2x plus 5. Okay, so we're going to need to break out our chain rule here a little bit. F, or g prime of x, is equal to f prime of 2x plus 5 multiplied by 2. Right? Derivative of the outside, leave the inside alone. multiplied by the derivative of the inside. So g prime, double prime of x will be the second derivative. We already have a 2 out there. Now we're going to multiply it by 2 again. So it's 4. Finally, the third derivative. That will be multiplied by 8. Okay. So now, because we talked about the fact that you can't really do a shift unless you have some kind of key to do it, a shift left or right. But I want you to think about this. G of 0 is the same as, if you plug 0 into both, 2 times 0 plus 5, well, that's the same as just f of 5, which we were given. That's 2. G prime of 0 is the same as f prime of 5 multiplied by 2. That's negative 4. G prime, double prime, of 0 is the same as f double prime of 0 multiplied by 4, so that's negative 4. And G triple prime of 0 is the same as f triple prime of 0 multiplied by 8. So that's 48. Okay, so let's build our Maclaurin series. Remember, it's around x equals 0. So we'd have 2x minus 0 to the 0 over 0 factorial minus 4, because that's the value of the derivative, x minus 0 to the first, or 1 factorial, 4 x minus 0 squared, 2 factorial, and 48. And I know you wouldn't really need to put the x minus 0. I just usually put it just to kind of remain consistent and make it look like a Taylor. But you wouldn't really need to do that. So we're going to get 2 minus 4x minus 2x squared plus 8x cubed. And that is our Maclaurin series for G.